one more type of ionic equation that we're going to write and what's going to happen there. So here I have HBr and KF. So I'm going to have my H plus, Br minus. I'm going to split these up into the ions. So I know what ions I'm playing with. I'll write my cations over here. I've got an H plus, I've got an F minus, and an F minus K plus, K plus. And then I'm going to switch. I've got my F minus over here and my Br minus on this side. Crisscross, I've got HF and KBr. Okay, so right away you should notice that HBr is an acid because it's got the hydrogen in front, and then over here you also have an acid. HBr is a strong acid. This is a strong acid, and HF is a weak acid. All right, so we go to our table of strong acids, weak acids, just right off the bat there. You can see that HBr is a strong acid, and HF is an acid. It's got a hydrogen in front, but it's not on the list, so it's going to be a weak acid. And it doesn't have an OH after it, so we know it's not water. So that's going to be a weak acid. So let's just follow the steps. Let's go back to our steps and make sure we're following them. All right, so crisscross, we found our products. We didn't bring over any subscripts. We balanced. Is everything balanced? Everything's balanced. I've got 1 to 1 to 1 to 1. Great. And then I can figure out which of these things are they soluble? Well, acids are always going to be soluble here. This is a soluble weak acid. So KBr, what do you remember about potassium? Potassium's on the always soluble list because it's a group 1 metal. So you can go to here, you see potassium is a group 1, or you can go back to the solubility table. And what am I looking at? KBr, bromides are usually soluble except with silver, lead, and mercury, and potassium is not on that list. So this guy is aqueous. So at this point, you may look at all those and say, oh, everything's aqueous. There's no reaction going on there. Great, easy done, except what? Except that this is a strong acid, so that's a strong electrolyte. This is a soluble ionic compound, so it's a strong electrolyte. But this guy's a weak acid. He's a weak acid, which means he doesn't dissociate into ions. That means this reaction, you are forming a weak acid. This is a soluble ionic compound. So if we dissociate these into ions, we get H plus, Br minus, K plus, and F minus. So that's a strong acid, which is why it's associated. But over here, this is a weak acid. He's going to stay together. So even though he's aqueous, he doesn't dissociate into ions. He is not a soluble ionic compound. He's a molecular compound. He's a weak acid. So weak acids are weak electrolytes. They don't dissociate into ions. KBr is a soluble ionic compound, so he's a strong electrolyte. He will dissociate into ions. So then we can cancel things that are the same on both sides. All right, so I've got potassium, I've got bromine, and so my final net ionic equation looks like H plus, F minus, gets me HF, and that's what happens when we form a weak acid. My spectator ions are potassium and bromine. So yeah, just be careful with the weak acids. And you can also have a weak acid on the reactant side, like over here, H3PO4 is a weak acid. So we could split it up in ions over here just to form our products, but when we go into the complete ionic equation, we're going to keep that guy together. Down here for this one with a solid, same idea. You're going to split it up just to make your products, but when you write the complete in the net ionic equation, that guy will stay together. And just a heads up, in H, you'll also form a weak acid.